Happy Monday morning. All we did last time was review. Right? So we're actually going to start pre-calc. Of course, we start by looking at what a function is. So relation, set of ordered pairs. You're familiar with relations already. X squared plus y squared equals 1 is a relation. It's the relation for the unit circle. Set of the first components of each ordered pair is the domain. So the second component is the range. So typically relations are ordered pairs x comma y. All of the x's are your domain, all of your y's are the range. Which is here. Each value in the domain is also called an input, or the independent variable, typically represented with an x. And each value in the range is also called an output, or the dependent variable, and is often labeled y. So you've been working with relations since pre-algebra, actually. We now take it a step further. And look at what's called a function. So you've also worked with functions in algebra, but they didn't call them that. A function is a relation. Specifically, it's a relation in which each input value leads to exactly one output. And we say that the output is a function of an input. So y is a function of x. So the input can only go to one output. But notice what it doesn't say there. It doesn't say that each output can only have a single input. So for example, the relation y equals x squared. That's a function. Each x goes to only one y. But with the exception of 0, each y has two x's that map to it. Right? 4. Both +2 and -2 will map to it. The circle relation, x squared plus y squared equals r squared. So I'll just use the unit circle, x squared plus y squared equals 1, is not a function. Each x maps to 2 y's. The positive and the negative. So again, your input values make up the domain. Output values make up the range. Typically represent functions y equals f of x. F is your function. X would be your independent variable, your input. Y is the dependent variable, the output. Okay. Easy way to remember that. Y depends on the value of x. So it's dependent. Which is stated again there. You may also see a function written that way. So that says that f is a function from the domain D to the range R. It takes values in the first set D and maps them to the second set R. So I have to be careful with terminology. So you have to find the function x squared, f of x equals x squared. Typically, we'll see that written as f is a function from the reals to the reals. So domain would be all real numbers, but the range is not all real numbers. Can you get a negative real number from x squared? Not if you're just considering real numbers, right? The reals, that second set there is what we would call the codomain. The range is all of the outputs you can get. But it's kind of a pain to write it for x squared. If I wanted to write it that way, I'd have to write it. 0 union with the positive real numbers would be the range. All non-negative reals. That's how you would represent the range of x squared. Again, it's kind of a pain to write, so we just write the reals as the codomain. You're not going to have to worry about codomain in this course, but you may hear me refer to it as codomain. So that's just what I mean. It's the second set. You don't have to worry about that unless you're a math major and you actually study functions and function analysis. Difference quotient, now this is important. I assume most, if not all, are moving on to Calc 1, which means you'll be working with the difference quotient a lot. Difference quotient for a function f is the value f of x plus h minus f of x all over h. H represents the increment change of x. And it can also be denoted as delta x. Let's call that our function f of x. Let's call that our point x. That would be our point x plus h, that second point. And first, we're going to have a coordinate, a y coordinate of f of x, and second point has a y coordinate of f of x plus h. It's a different color. Don't happen to know what that line is called? So that is when you talk about trying to fit data points into a line. Typically, you need more than 2 data points for that. It's called a secant line. A secant line is just a line that connects 2 points of a function. What's the slope of a secant? What is the slope of a line? This is algebra 1. Oh, that's not good.
I mean, is it change in y over change of x, right? I just didn't know if there was a formula.
That is the formula.
So like y2 minus, okay.
Change y over change of x.
Yeah, okay.
Rise over run.
Yeah.
Well, second point. Y value. F of x plus h, right? Minus y1. x2 minus x1. F of x plus h minus f of x all over h, which is the difference quotient. So the difference quotient is also the slope of the secant line connecting the 2 points. We'll expand on that in Calc 1. There are a few ways to represent domain. So you have to remember domain is a set. You can represent by drawing out the number line, which we don't do. You could also use what's known as interval notation. We're all familiar with that. And that's algebra. You have inequalities, which we typically don't use. And then also set builder notation. Right, so these next 2 slides kind of review inequalities and interval notation. Finding the domain. So remember, domain of a function is the set of input values It's the set of values that the function can accept. Right now, we only have two rules that we have to worry about. Start with all real numbers. And then we remove any restrictions. As I said, as of right now, there's only two. First one. Has to deal with if you see a fraction. What are you not allowed to divide by?
Zero.
So if you see a fraction, your denominator cannot be 0. The second has to deal with radicals. Two types of radicals. You have an even index and an odd index. Right? Square root would be even index, cube root is odd. Dealing with the real numbers, what can't you take the square root of? What's the square root of 4?
2.
Square root of 1? Square root of 0?
Zero.
0. Square root of -1?
Yeah, negatives. Can't take negatives.
Can't have a negative under an even indexed radical. At least not in the reals. If you study complex valued functions, you can. That is a whole different ballgame. No. Calculus is the study of real valued functions. You don't cover that until complex, which is a senior level math course. And even then, it's just an introduction. You really don't touch on until grad. All right, so our purpose is we're studying real valued functions. So if you have an even indexed radical, what's under the radical, I actually should fix that, must be non-negative. Yeah, of course it reset it. That is actually an important distinction between non-negative and positive. Positive doesn't include 0. 0 is the only number that's neither positive nor negative. Let me rephrase that. The only real number that's neither positive nor negative. And then as we study different types of functions, the exponential, logarithmic, and trig and inverse trig, we'll learn more restrictions. does this relation define y as a function of x?
Yes.
Remember, what does it mean to be a function? Each x can map to only one y. So if you pick any x value, do you only get one y value? Yes. This one's easy to see. Oops. That's right. Not right. So that one is a function. What about x equals y squared plus 5? So algebraically, we try to solve for y. Right. First step, isolate y. So subtract 5. How do you undo a square? What is the square root of y squared?
Y.
It's a very common misconception. It's not y. It's the absolute value of y. Again, square root of 4, we know is 2. But negative 2 squared is 4, right? So if you take the square root of negative 2 squared, you don't get negative 2. You get positive 2. You get the absolute value of negative 2. That's why it's absolute value. That means you get 2 values for each y. Positive square root and the negative square root. You don't get just one, so it's not a function. We could say x is a function of y, though, if we make x the dependent and y the independent. I think this one's fairly, yeah, this one's also straightforward. What about y equals square root of x minus 5? Yes, that is a function. Each x value will only give you one y value. What about y equals 5?
Yes.
That's why I hear a no, yes. Why do you say no?
No x value.
Okay. Why do you say yes?
This is not like very. Yeah, I just remember in math class they told us like if you do a
Math class. Which math class?
I don't know, this was a long time ago. They're like, you put a vertical line in the function and it's like.
So that's the vertical line test.
Yeah, that's what it's called. Yeah.
That's when you deal with
y
graphs.
equals 5. So is it a function?
This is a function. It's true there's no x there. So if I say when x is 8, what's y? When x is 20, what's y? Each x value is only giving you one y value, right? So this is a function. Specifically, this is called the constant function. Right? Yes, there is the vertical line test, which I tend not to look at too much. I try to focus on the algebraic interpretations, not geometric.
That makes more sense.
Not yet, anyway.
Right.
We'll deal with that when we start looking at graphs, which we do unfortunately have to do. They do require me to sketch graphs. Just stupid, that's what Calc 1 is for. X squared minus y squared equals 36. So this defining function, or would this define y as a function of x? Again, solve for y. X squared minus 36 would be y squared. Once again, you'd get the absolute value of y is equal to the square root of x squared minus 36. Let's have a tiny pop quiz. Can you simplify the square root of x squared minus 36? Pleasure. And if so, how? No, it cannot be. Good, you passed. Remember, square root does not distribute across addition and subtraction. A mistake that sadly too many people make even in my differential equations courses. Which is one of the last math courses you take as a sophomore before you hit the upper level courses. I'll just go ahead and get this out of the way now. Math is a language, which means it has its own characters, let's call it. That is the symbol for or. So if you see me write that, that's what I mean. So I could just write this here.
Just like a V.
Try and introduce the shorthand, the language as we go, as I use it. I've already been using shorthand. Double arrows implies. Or if then. Evaluating functions. Really simple. So here we have a function defined as f of x, x squared minus 4x plus 2. We're being asked to evaluate several values. Just start with f of 5. So a very important distinction, that is not f times 5. That is f of 5. The function is a rule. Right? So the function f is telling you to do something to your input. Tells you to square it, subtract 4 times the input from it, and then add 2. The input in this case is 5. So we first have to square it. Subtract from that 4 times the value, the input, and then add 2. Which means all I have to do is replace x with 5. Five squared. What's 4 times 5? 25 minus 20. Add 2.
7.
F of 5 is 7. F of negative 3. The input is now negative 3. Look in the definition of f. Everywhere you see an x, replace it with negative 3. And do so carefully. So look up top. Is that a true statement? No, it's not. The left-hand side evaluates to what? What about the right-hand side? Negative 9. That's why I mean replace it carefully. Let's say that does not equal. What's negative 3 squared?
9.
4 times negative 3.
Negative 12.
So we have 9 minus negative 12, which is what?
Plus 12. 21.
Add 2.
23. Wait, what are you talking about? How that's negative 3 squared equals negative 9 up top. I
The
don't know-
right-hand side?
Yeah, I don't know the difference between those two.
PEMDAS.
Like the parentheses you're talking about up top?
So left-hand side is 9, right? You agree with that?
Yeah, I agree.
Right-hand side. It's saying first you square 3, and then multiply by minus 1. 3 squared is?
It's 9.
Times minus 1.
Okay,
That's why the parentheses are important.
got it.
F of negative 3 is 23. But you don't have to just plug in a known value. You can plug in some unknown constant, call it A. F of A would just be A squared minus 4A plus 2. Again, same rule. All you're doing is replacing X with A. What's the input now? A plus B. Replace X with A plus B. You can.
So it's like A squared plus 2AB plus B squared.
What is the second simplify to?
Negative 4A, subtract 40 plus 3.
Really can't be simplified. Now, I'm going to write it in standard form. That would be standard form. It's not necessary. I'd accept that first one as well. Well, not the first, the second thing that we wrote. I'd accept that. So what about f of A plus f of B? Be that, right? Simplified.
Subtract 4A, subtract 4B plus 4.
Is that the same as f of A plus B? No. In general, f of A plus B will not equal f of A plus f of B. If it satisfies that property along with one additional property, then we say the function's linear. Again, that's not something you have to worry about. You'll study that if you take linear algebra. So there's also a special type of function known as a piecewise function, or a piecewise defined function. And it's just as you think, it's broken into pieces. These are, again, fairly straightforward rules. So let's start with -3. -3, is that less than or equal to -2?
It's less than.
So it goes into that first piece. What's the absolute value of -3?
3.
Times -2
-6.
minus 3.
-9.
G of -3 is -9. G of 3, is 3 less than or equal to -2?
No.
Is 3 between -2 and 3?
No.
No. Is 3 greater than or equal to 3?
Yeah.
So that's the piece it goes into. What's G of 3?
4.
That's all a piecewise function is. So g of negative 2, what piece?
First
What is that going to evaluate to?
-7.
G of 0, what piece?
Second column.
And finally, down here, g of 4, what piece?
Last one.
So what is it going to evaluate to? 4.
So you're just applying and putting in.
But now you have to look at which piece is it going to go into. Let's say I make a slight change. Instead of the first piece being x less than or equal to -2, it's just less than -2. Then what would g of -2 evaluate out to?
Doesn't exist.
It would not exist.
Wait, how are you getting -7 and -9? With G of -2.
So you know how we're deciding what piece to go into?
Yeah. I
Okay.
understand that.
So what is the absolute value of -3?
3. Oh,
Times -3, or times -2 rather,
yeah, which makes 6.
and then -3.
Okay. So
Same thing with the -2.
So it's -4 subtract 3.
Yes.
Okay. Second one.
F of 1.99.
Three 3.98.
3.98. F of 0.4.
First one.
Oh, that one's nice. Just 0.4. F of 3.
Third.
F of 1.
First one. Last one.
What's that?
4 times 3.001. What was it?
12.004.
Yeah. 12.004. Easy, right? I think with the exception of Calc 2, most math courses do start off really simple.
Is this gonna be like the first thing we're learning? Just go.
This is all just part of functions. We're just looking at some basic definitions right now of functions before we actually study functions more in depth. Calc 2, depending on how it's taught, starts off actually the hardest and then gets easier. Just a fair warning if you have to take Calc 2. Calc 3 is actually the opposite. Starts off really easy, and then by the end, you're just praying that you pass. Calc 2 starts off extremely hard, and then by the end, you're going, oh, I got this. Calc 1 is just Calc 1. Difference quotient. So remember what the difference quotient is. That's what we're looking for. And this is probably the most important thing we're doing today, is finding difference quotients. Now, you can do it all in one step. It makes the algebra look more intimidating than it actually is. So I think I will do it all in one step for this one. F of x plus h. So look at f. Replace x with x plus h. So there's f of x plus h. Minus f of x. And then all over h.
Why are we using a bracket?
Less confusing.
Oh, right.
You don't have to. I actually typically don't. I'll just use nested parentheses. Simplify. So we distribute that -3 through, right? Then just plus 8. We're now distributing a negative through.
Plus 3x minus
-3x plus 3x is 0. Plus 8 minus 8 is 0. H over h is 1. You get -3. That is technically not a true statement.
Why?
I'm so glad you asked, because that's what I was going to ask. Does anyone know why that's not a true statement?
But it's a negative.
Can be negative, that's fine.
Because there's no denominator.
In the final answer?
Are you supposed to leave it with the h's because
No, you just simplify out the h's.
so
Because it's odd.
But technically how I wrote it is not a true statement. What happens if h is 0?
it's not.
It's not even just not a real number. It's just not defined. If h is 0, you get 0 over 0. Is that the same as negative 3? No, it's not. They're not equal. They're only equal if h is not 0. So technically, I should write for h not equal to 0. However, it is assumed when doing difference quotient that h is non-zero because it is an increment change of x. Well, if h is 0, then you don't have a change in x, which defeats the purpose of the difference quotient. So the h being non-zero is implied in difference quotient, which is why I'm not writing it.
So we don't ever have to.
No. Not for difference quotient. When you're simplifying rationals, you will have to specify, and we'll get to that. That is what's called an implicit assumption, or I guess you'd also know it as an unwritten rule. Nice. Oh, by the way, in Calc 1, there's just one more step you take from that, and that's to pass it through a limit, which is actually extremely easy, because that limit's negative 3. So the derivative of that function is negative 3. Calculus is easy. Algebra's hard. 90% of your work in calculus is algebra. The other 10% is calc. And that's being generous. It's actually less than 10% is calculus. The rest of it's typically algebra. I've had 9-page solutions. Less than half the page was actual calculus. The other 8.5 pages was all algebra. It's also true in physics. The physics itself I found very easy. It was the actual math of it that was insane. For this one, I'm going to break it down into steps. And then I'll let you choose whichever route you want to go, whether you want to do it all at once or try and break it down into steps. So first, evaluate and fully simplify f of x plus h. Start by replacing x with x plus h, right? Is that fully simplified? So what can you do?
Distribute
Distribute what?
before the negative 2.
Can you distribute the negative 4? We technically can, but it's going to make it a lot more difficult.
Never mind. Let's not do that.
Because what you have to do is distribute the 4 in as a 16. You have to square it before you can put it in there. No, I'm sorry, you have to take the square root before you put it in there. So you have to put it into 2. So we'll wait to do that one. But I do agree you can distribute that -2 through. But you can do something to the first term.
Yeah, you do x plus h and then x plus h.
What's that process known as? FOIL is just a special name given to if it's a binomial times a binomial. It's the opposite of factor. Expand.
So x squared.
So you can expand out the x plus h squared. I'll distribute that -2 through. Is that fully simplified?
No,
What can you do?
negative 4x squared.
Right. Now you can distribute the -4 through, right? Is that fully simplified?
Yeah.
I would agree that's not fully simplified. Take what you just found. Subtract from it f of x and fully simplify. -4x squared minus -4x squared.
Positive 4x squared. Once.
That's 8x squared. I don't know. I'm not.
So -4x squared minus -4x squared.
0.
0.
Oh.
-2x minus -2x. 6 minus 6.
You didn't cross out the negatives.
I did. Okay. Is that fully simplified?
No,
What can you do?
take out the h's. So it's divided.
You can actually do more than just take out an h.
Yeah.
2.
A what?
That's
Yeah.
More than just a 2h.
a negative.
Yeah, I can factor out a -2h if I really wanted to. What are you left with?
4x plus 2h. And then
Plus 1. That would be fully simplified. It is not necessary to factor out a -2. If you factor out a 2, you're still technically correct. At that point, it's just aesthetics. I don't like negatives. So I write as few negatives as possible. Final step. Take what you just calculated, divide it by h and fully simplify. What was it? It was then 4x plus 2h plus 1. H over h is 1. That would be your difference quotient. You could, and I probably would,
So like we don't have to do that step 4, we can just back out, or I mean, just
Yeah.
divide out the h by 12.
because for calc, this is going to be the easier form. So you have to be careful. You have to actually pay attention to what the question is asking. If the question is asking for fully simplified, you'd have to write the first solution, the first answer. You have to factor out the -2. If it doesn't ask for full simplification, I would accept either one. And then in calculus, there's just one more step. Pass it through a limit. The derivative is -8x minus 2. So I don't care which step, I don't care which process you use, whether you want to do it all at once or try and break it down in steps to make it look less intimidating. How I do it will probably depend on my mood. It is. For the sake of time, let me skip to finding domains and then come back to that as time permits. Either today, tomorrow, or not Wednesday, at some point if I have a short lesson. So finding domains, this is probably the second most important thing we do today. Because a lot of the time, when you're given a function, the domain is implied. It's not explicitly stated. So you need to be able to determine what the domain is. So remember, when finding domain, you first start with all real numbers. Then you remove any restrictions. And there are two restrictions that we have right now. Denominators and even radicals. Is there a denominator?
No.
Is there an even index radical?
No.
There's no restriction to remove your domains, all real numbers. Two ways to write that. First, interval notation. Second is set notation.
Do you care which? Or do you get
Generally, no. If it specifies a specific method, obviously you have to do it that way.
So sometimes you'll ask for either.
If I don't, you can use whichever one you want. And I do use them interchangeably. Sometimes one method is more convenient to write than the other. And that's just the set of real numbers, the blackboard bold R. Are there any restrictions we have to consider?
Yeah,
Which one?
denominator being 0.
So x squared minus 9 cannot equal 0. That means x squared cannot be 9. Absolute value of x cannot be 3.
But it's your x is plus or minus 2.
Right, so x can't be negative 3. Actually, that's not important in this case. That's an and. And x can't be 3.
Why do you write the absolute value of x if you're just going to write x plus or minus 2?
To emphasize that when you take a square root, it's always absolute value. Because that does come into play. And again, also in this case, because which one's shorter to write, which one's easier to write? The absolute value of x is not equal to 3 or the other one.
Absolute value.
But they mean the exact same thing.
So you can take either one?
Yeah.
Or,
But when you start to do some more advanced mathematics and you're writing a lot of lines, you try to shorten it as much as possible. Are there any other restrictions to worry about? So now you take all real numbers, remove from that your restrictions. In this case, plus minus 3. That would be your interval notation. Set notation. That on the right is red. The set of all x that are real numbers, or the set of all real numbers x, such that the absolute value of x is not equal to 3. Since we're dealing with real valued functions, more likely than not, what was written in pink there will not be included. Because it'll be implied that we're just dealing with real numbers. But that would be the mathematically, grammatically correct way of writing it. Do we have any restrictions to consider? What's the restrictions? Denominator cannot be 0. How would we solve that?
GCO.
Hmm?
See the greatest common factor.
To factor. What is the GCD? That is what we're left with. Is that fully factored? How can we factor that?
Would be x, and then parentheses x plus 6, and then 2, and x minus 4. So x can equal 0, negative 6, and 4.
So for this one, we're going to use the corollary to the 0 property. The 0 property states if you take the product of real numbers and get 0, then at least one of those numbers had to be 0. The corollary to that is if you take the product of real numbers and it's not 0, then none of the numbers can be 0. Right? The only way you can get 0 out of a product is to multiply by 0. You don't have to write it in ascending order. However, it does make it easier. Any other restrictions?
Yeah, the x squared on top.
What's the restriction there?
That is an even.
X squared is an even root.
Did you say it can be odd? Like a number?
Well, I specifically said the index. Is there a radical? I agree 2 is even. But is it an index of a radical? So is that the second root? No. It's a second power, right?
Oh, yeah.
Not a second root.
Right.
So there's no radicals. So that's it. Those are the only restrictions. Interval notation. Here's where you can see interval notation is starting to lose its advantage. Because that's kind of a pain to write. and then that would be your set notation. Do we have any restrictions?
Is it the index?
What's the answer?
2.
Is 2 even? We have an even indexed radical. So what does that mean?
If it were like in parentheses x plus 5 and the whole thing is squared, that's what you're talking about. Like,
So that would be an even power.
So when it has to be in like a root? Okay.
So the index of a radical is just what's the root? In this case, square root is 2, right?
Mhm.
You could have a 4th root. The index there would be 4. 5th root index would be 5. So that's what I'm referring to. So for an even indexed radical, what has to be true?
It has to be non-negative.
What has to be non-negative?
Very,
The what?
the radical can't be non-negative.
What's in the radical
Yeah.
has to be non-negative, right?
Yes.
So in this case, the x plus 5.
Yes.
Right? If I had like a minus x outside, that x doesn't matter. It's just specifically what is under the radical has to be non-negative. So x plus 5 has to be greater than or equal to 0. Which means what?
X is greater than or equal to -5.
Are there any other restrictions? Nope, that's it. For interval notation, how would you write that?
Bracket. -5, comma, infinity. Parenthesis.
And then that would be the set notation. Set of all real numbers x such that x is greater than or equal to -5. What about here? What's the restriction? do we have to have?
Is it the index and the negative on the left?
What's the index? Which is even. So what do we have to have?
Inside can equal 0.
What's the inside?
X squared subtract 8x plus 12.
And not can't equal 0.
Real number.
How do you get a real number out of a radical? Specifically an even radical,
Has to be positive.
not just positive,
Greater than or equal to 0.
not negative. It can be 0.
Oh, right.
Now we have to solve that. Which means first we need breakpoints. Set equal to 0 and solve. Can that be factored?
Yes.
Where's the factor to?
X minus 6, like parenthesis, x minus 6, close parenthesis, and then x minus 2. Yeah.
So x could be 2 or 6. Those are 2 breakpoints.
When we write that, does it have to be that way, or can you write x equals to e6? Instead of writing x equal to
Mathematically, it should be x
that.
equals.
Mathematically, that's correct.
In terms of the syntax, if you just put or 6, that's not proper syntax.
Alright.
But I'm not that much of a stickler right now. That will be important as you advance in math, but right now, not really. You could even just put x equals 2 comma 6. So there's our 3 test intervals. Cool. First one has 0. That's nice. Plug 0 back into the expression, which is x squared minus 8x plus 12.
Wait, where's
You get positive or negative?
positive?
And so the expression I'm looking at is this one. Or, you could even put it in here. Either one. 2 to 6 has 4. Let me pick 4. Plug 4 back into the expression. 4 minus 6 is negative. 4 minus 2 is positive. What's negative times positive? And then 6 to infinity, 10 would work. You're going to get a positive, right?
Are you choosing a number based on like?
A number in the interval, yes.
Okay. I'm like, what's going
And it doesn't have to be the number I chose, just any number in that interval
on? You
works.
just plug it in between negative 6. Okay. Thanks.
What was the inequality? What was the inequality that we were solving?
x squared minus 8x plus 12 is greater than or equal to 0.
So the symbol is which one? Greater or less? Greater. So you take the positive interval. Can it be 0?
Yes.
That means your breakpoints are included.
Yes.
So if it was like negative infinity and then comma 0, like, what would that change? You can't include it.
No, 0 would still be included if it's or equals. If 0 happened to be a breakpoint. It would change the number that I picked and change my test value. That's it. Or is there any other restrictions we have to consider?
How do we know that it was greater?
Hmm?
How do we know that it was greater?
Because that was the inequality we were solving. That would be your interval notation for the domain. Set notation, set of all x such that x is less than or equal to 2 or x is greater than or equal to 6. Probably write that more succinctly, but that's beyond the scope of this course. Do we have restrictions? What are the restrictions? Hmm?
Negative 8. I guess
What about negative 8?
that's a negative.
So, so you see the radical, which is good. What's the index of the radical? What is it?
3.
Is that even or odd?
So,
Does that give us a restriction? So there's no restriction with the radical. What about it? Hmm?
Because it's on the ball.
Right, so what about x cubed minus 8?
Or,
Yeah. All right, so technically it's not x cubed minus 8 that can't equal 0. It's going to wind up being that.
Oh, the x cubed can't equal 8.
It's the cube root that can't be 0. Because remember, the cube root splits across the numerator and the denominator. And so technically speaking, the denominator is the cube root of x cubed minus 8. However, that doesn't matter, because ultimately what that's going to mean is that x cubed minus 8 itself can't be 0. Well, that means x cubed can't be 8, right? So what can't x be? Any other restrictions? Or is that it? So domain is all real numbers except for 2. Any questions? Determining domain may seem weird at first, a little difficult at first. Just get the hang of it, it's fairly straightforward. It's not too terrible. And it's just remembering what restrictions you have. So remember, denominator cannot be 0. You can't take an even index radical of a negative number. Again, these are a list of the assignments that are coming up to be due. Enjoy the rest of your day. See you Wednesday.